According to the orbital overlap concept, a covalent bond is formed when a half-filled valential atomic orbital AO of one atom overlaps with a half-filled valential atomic orbital of another atom containing electron of opposite spin. Covalent bonds can be classified into two types depending upon the types of overlapping adopted by the atomic orbital. That is, one is sigma bond and another one is pi bond. Sigma bond, a bond formed between two atoms by the head-on overlapping of atomic orbitals along the internuclear axis called a sigma bond. Head-on overlapping of atomic orbitals. This kind of overlapping result in a sigma bond is also referred to as an axial or end-to-end overlapping. Also referred to as a axial or end-to-end overlapping. SS overlap. SS overlap involves overlap of half-filled s orbital of two atoms along the internuclear axis. Example, overlap of 1s orbital of a hydrogen atom with 1s orbital of another hydrogen atom result in the formation of H2 molecule containing a HH sigma bond. SP overlap. SP overlap involves overlap of a half-filled s orbital of one atom with a half-filled p orbital of another atom along the internuclear axis. Example, overlap of 1s orbital of a hydrogen atom with a half-filled 2p orbital of fluorine atom result in the formation of HF molecule containing hydrogen fluorine sigma bond. In hydrogen fluorine sigma bond, 1s orbital of hydrogen atom and 2p orbital of fluorine atom overlap and form a HF sigma bond. PP overlap. PP overlap involves a half-filled p orbital of two atoms along the internuclear axis. Example, overlap of 3p orbital of a chlorine atom with a half-filled 3p orbital of another chlorine atom result in the formation of chlorine molecule containing a Cl-Cl sigma bond. Here, one 3p orbital of chlorine atom overlap with another 3p orbital of another chlorine atom and form a chlorine-chlorine sigma bond. Pi bond. A bond formed by sideways overlap of atomic orbital is called a pi bond. Sideways overlap. In the formation of pi bond, the atomic orbital generally overlap in such a way that their axes remain parallel to each other and perpendicular to the internuclear axis. Their axes remain parallel to each other and perpendicular to the internuclear axis. The orbitals formed due to the sideways overlapping consist of two saucer-type charged clouds above and below plane of the participating atoms. Since extensive overlap of the concerned atomic orbital is not possible in this sideways fashion, a pi bond is a weak bond. Simply, a pi bond is a weaker bond than sigma bond. Difference between sigma bond and pi bond. Sigma bond. The bond is formed by the axial overlapping of atomic orbital, whereas pi bond, the bond formed by the sideways overlapping of atomic orbitals. Second point, sigma bond can be formed by SS, SP or PP orbitals. Pi bond, it involves of overlapping of p orbitals only. Then third point, the bond is a sigma bond is a stronger because overlapping can take place into a larger extent, whereas pi bond is weaker because the overlapping occurs to a smaller extent. Then fourth point, the molecular orbital is symmetrical about the internuclear axis and consists of a single charged cloud. P orbital. The molecular orbital is discontinuous and consists of two charged clouds above and below the plane of atoms. Fifth point, sigma bond. There can be a free rotation of atoms around a bond, whereas in pi bond, free rotation of atoms around pi bond is not possible because it is involved breaking of pi bond. The last point is sigma bond. The shape of molecule is determined by the sigma bond frame work around the central atom, whereas in pi bond, the pi bond does not contribute the shape. However, they modify the dimension of the molecule. Okay, these 6 points are the difference between the sigma bond and the pi bond.